Okay, so now suppose we have like 7 data points as well. But now you see we are not going to try to find the least square approximation by a line, but we try to find the least square approximation by a parabola. So what it means is I try to find a green parabola that minimized the square residuals, the sum of the residuals. So the residual, like R1 is the difference between the curve and the first data point, and R2 is the difference between the second data point and the line on the point on the curve. So how do we do that? So we have to write down R1 is yt1 minus y1, and in our case yt1 now is this a0 plus a1 t1 plus a2 t1 square minus y1. Okay, and then R2 is the curve at the point t2 minus the second data point is a0 plus a1 t2 plus a2 t2 square minus a2, and so on up to R7 is y t7 minus y7, a0 plus a1 t7 plus a2 t7 square minus y7. So now we can write down in terms of a vector. So vector residual vector is R1, R2, ... up to R7. And now we write in terms of a matrix. So the matrix, you can see that there's an unknown coefficient A0, A1, and A2, right? And the coefficient for the matrix, it will be 1, then T1 square. And then the second one will be 1, T2 square, and so on. So up to the last one is 1 T7 square, and minus the data points. So y1, y2 up to y7. Okay, so that is, we can write out this one is a coefficient matrix, and this is the vector x, and this is the vector y. So now you see that the coefficient matrix is different from the case when we have a line. So for a curve, then the coefficient matrix has 3 columns. The first one is 1, second one is t, and the last one is t square. So, and you have 3 unknowns here, and then you try to minimize the residual square as before.